Assalamualaikum warahmatullahi taala wabarakatuh. So today we will present to you guys about smart agriculture system for our subject Introduction to Industrial Information Technology. So this is our group members. My name is Ahmad Helmi bin Muhammad Rizwan, student ID 502251222230, and this is our group member.
Tadi belakang tu.
So for introduction, the word technology is currently moving towards the application of IoT, the Internet of Things. It's a system of interrelated computing device, mechanical and digital machine, objects, animals or people that are provided with unique identifier, as known as UID, and the ability to transfer data over a network without requiring human to human or human to computer interaction. So this is our general overview about the system. First is smart farming is a management concept focused on including big data, the cloud, and the Internet of Things for tracking, monitoring, automating, and analyzing operations. Smart farming is growing in importance due to the combination of the expanding global, the increasing demand for higher crop yield, the need to use natural resource efficiently, the rising use and sophistication of information and communication technology, and the increasing need for climate smart agriculture. So this is the review on 3 similar systems that does not use IoT. This is we call an old method, which is first agroforestry. Agroforestry is one of the oldest farming methods that has been used since earlier times. It is basically planting and maintaining trees that can protect the crops by developing the microclimate. Next, water harvesting. This method used to collect and store rainwater which can be used later for agriculture purpose. It is either collect from a roof like surface or store deep pit in a well. Next, we have crop rotation. Crop rotation concept was founded by world-renowned environmentalist, which is Dr. Vandana Shiva. The practice of growing different crops on the same land based on season is crop rotation. It has a lot of advantage. It helps in preserving the soil productivity, reducing pests, minimizing use of chemicals, maximize yield, reducing reliance on one set of nutrient and developing weeds. Next, I will pass to one of the member, which is Mirza Haikal.
The
The
next
next
is
is
justification
justification
on
on
why the
why the
system
system
needs
needs
to
to
be
be
integrated
integrated
with
with
IoT.
IoT.
The
The
application
application
of
of
the
the
IoT
IoT
in
in
agriculture
agriculture
promises
promises
traditional,
traditionally
sustainable
unattainable
efficiency,
efficiency,
resource
resource
and
and
expense
expense
reduction,
reduction,
automation
automation,
and
and
data.
data-driven operations. This proposed system will help in reducing the amount of water using to grow the plant. In addition, this is also will help to decrease the waste of water. Farmers will get correct timing for fertilizing and treatment of soil to maximize the quality of product. By this, the farmers will not waste their fertilizer, and that it also will not give any harms for natural ecosystem and even make it better. Plus, the rate of productivity will go higher, and that make a positive impact on economic outlook. The farmers the farmers will get to minimize their cost for production by this proposed system. And that's the component involved, which is humidity and temperature, soil pH sensor. For humidity and temperature, this sensor automate moisture temperature and easy monitoring, and that it allow for effective and waste-free watering. For soil pH sensor, it refers to the current pH of the soil, which plays an important role in the growth of plant. Plant can grow normally in a wide range, but various plants have their suitable pH. Soil moisture, soil water content is the driving force for plant growth. When the water content in the soil is relatively high, the water in the plant will enter the body of the plant through the membrane of the root system, accompanied by many inorganic nutrients in the soil. However, when the water content in the soil is insufficient, the concentration in the root system of the plant is lower than the growth environment of the outside world. And then the software involved is Proteus 8 Professional and Arduino CC. For Proteus, we can simulate the circuit with Proteus by uploading hex code to the microcontroller, but not with multism when simulating circuits using microcontrollers. If necessary, the tools option in this program allows you to extract a netlist file which is written in Verilog code. For Arduino is an open source electronics platform based on easy to use hardware and software. And then Arduino boards are able to read input like on a sensor, a finger on a button, or a Twitter message, and turn it into an output, activating a motor, turning on an LED, publishing something online.
Okay, the next one is our overall system flow, which is our flow chart. So when the system start, it will read the soil moisture, air temperature, and ground pH level in a digital value, and then it will send a code to the microcontroller, which is the Arduino, and then the Arduino will process the three parts of the criteria for plant growth. Air temperature, the temperature should be between 27 degrees Celsius and 21 degrees Celsius. The soil moisture should be at SI 5, 6 or 7, and the ground pH should be above 5 and less than 7. If the statements are false, a certain command will be performed. For example, the temperature will turn on the heater or cooler, the soil moisture will turn on the sprinkler, and the ground pH will turn on the fertilizer machine. If the optimum criteria is met, which means the statement is true, then the condition will be maintained and the loop will cycle again. So this is the a version of our Proteus circuit for the agricultural system. So the Arduino Uno will be the controller for this smart agricultural system, and all the logic toggle each would represent the three types of sensor that are in the system, which are temperature and humidity sensor, pH sensor, and soil moisture sensor. All those sensors are not put into the Proteus due to it cannot be found in the library of the Proteus. And the output will be represented with LED lights. So the first LED to represent the sprinkler, the second to represent the heater or cooler, and the last one is to represent the fertilizer machine. The virtual terminal will represent the user interface for the system. So this is the process and activities offered by the system. When the sensors give an input that doesn't satisfy the desired condition, some action will be taken to improve the situation. If, for example, it does not satisfy the condition of the temperature, the heater will be turned on so that the temperature will go back to its desired value. After the loop, the temperature will be checked again until it suits the condition, then the temperature will be maintained. So this is the example for other two sensor. The first one, the second one would be the soil condition sensor. A sensor would be placed in the soil to estimate the acidity of the soil for agricultural to grow. This is basically to measure the pH level of the soil suitable for plant growth. So if the acidity is over the desired pH value of the plant, a machine will add fertilizer to the soil until the optimum pH is met. And this process will go on until the system is turned off. Lastly is the soil moisture level that will be calculated in terms of Sensoterra index, which is 1 to 10. 1 to 3 means it is too low. 4 to 6, which is the optimum condition, and 7 to 10 will be too high moisture in the soil. If the moisture is too low, then a sprinkler will be turned on. If the moisture is too high, then the temperature will be increased. This is the view of user interface that we created. So as you can see, there is a very simplistic design on the right side of the presentation. So there is 3 scales for each input and 3 buttons for each output. In the future, more type of input and output can be added into the system to make the system more complex and more functional. So if the scale is in the optimum condition, then it will turn to a green color. If it is not, then it will turn into a red color. The scale bar will be at the middle section of the scale if it is in optimum range. And then at the bottom, the digital value of the measured unit will be shown. At the side, the 3 buttons can be pressed and or turned on automatically by the sensors, depending on the user. The proposed design, this is basically the optimum design that we planned for, which is in a greenhouse. Basically, the design will take place in greenhouse or an agricultural factory. The sensor will be put in every 1 meter squared of the area so that it will be calculated with precision. At each sensor, the data will be transmitted to the edge computer, which is a controller. In this system, the controller will be our Arduino. The coding will run in the Arduino to check the optimum condition, and the output device will be turned on if needed. At the same time, the data will be shown on the screen of our phone or tablet using the cloud.
Okay, the advantages of the system. Real-time data from linked device and sensor can be collected and analyzed when a system is integrated with the Internet of Things. This may result in several advantages, including process automation and improved efficiency, better decision making, better monitoring and control. Better monitoring and control, IoT devices can be used to monitor and control equipment, facilities, and other assets, allowing for early detection of issues and proactive maintenance. Next. This one is business opportunity. We have 4 example of business opportunity points. 4 points. By collecting and analyzing data from IoT devices, the system may predict when buildings or equipment may require maintenance. IoT devices can be used for surveillance and security, which can be offered as a service to business wishing to improve their security. The technology can be used to develop smart products and services that can be customized to meet the individual's needs of clients. IoT as a service. The system can be made available as a service to assist businesses and connecting their equipment to the internet, giving them a full IoT solution. Next. This is the target users and customer. Target users. Our mission is to target the greenhouse in all channels by delivering outstanding value to use our source and experiences by fulfilling smart agriculture system.
And the target customers, we are targeting to all the owner of agriculture industry to buy and use our system. In the coming decades of digitalization and automation, smart agriculture techniques will be a significant option to develop healthy crops on a large scale. So the conclusion of our project is the Internet of Things application in agriculture are aimed at conventional farming operation in order to fulfill rising demand and reduce production losses. Robots, drones, remote sensors, and computer imagery, along with ever-improving machine learning and analytical tools, are used in agriculture to monitor crops, survey and map fields, and provide data to farmers for sensible farm management plans, saving both time and money. So that's all for our group. Thank you.